Today I'll be presenting about my math assignment statistics, and I have got a claim from Ministry of Manpower. The Ministry of Manpower in Singapore has conducted studies on how many hours do people work per week. They found that it was 43.3 hours per week as of June 2023. To validate this claim at the 5% significance level, I've collected sample data from over 30 people, more specifically 33 people, as you can see in data collected at column A. The null hypothesis is that the hours worked per week is 43.3 hours, where mu equals to 43.3 hours. Alternative hypothesis is that the hours worked per week is not 43.3 hours, where mu does not equal to 43.3 hours. The reason for alternative hypothesis is to use sample statistics to verify a claim about population mean under certain probabilistic conditions, which tell us whether to reject the null hypothesis or not. To test for the alternative hypothesis, I have collected sample data from over 30 people, which could be used to test whether the claim is true or not, as it is relevant to the claim given its numerical quantity and relation to the claim. For the alternative hypothesis, I have used the two-tailed test, as my data fluctuates in a range with above, I cannot tell whether the majority is above the mu or lesser than the mu, which is 43.3. To calculate the sample mean, which is 41.6691, the formula used is here, as you can see here, where sigma is the sum of all x values over the number of items. For sample standard deviation, which is 6.27204, as you can see here, and here, you can see the formula here too, which is the squared sum of the values of the data minus the mean of the value over the number of data points minus 1. For the test statistic equals to negative 1.438. To calculate the test statistic, the formula used is over here, where x bar is the sample mean minus the mu, which is 43.3, over the standard deviation, which is over the square root of the sample size. For the p-value, to calculate p-value, we use the formula of xi using two-tailed hypothesis. We use the t-statistics above with n minus 1, where n is sample size. As you can see here, p-value equals to 0.145036666, which is greater than 0.05, which is the alpha, which is the significance 5% significance level. Thus, there is insufficient evidence to reject the null hypothesis. For the 95% confidence interval for population mean is 39.4451, which is less than mu, and 43.8931, which is greater than mu. To get the margin of error, we use the formula for t distribution. This is the margin of error, where E equals to 2.22397. To get the margin of error, we use the formula for t distribution, which is where alpha is the significance level and n is sample size, with s being standard deviation in this formula. The t-test was chosen as the population standard deviation wasn't given, and the alternative was the t-test, which used the sample standard deviation. I derived at the conclusion based on a 5% significance level, and the p-value is greater than 0.05. This means that we have either insufficient evidence or examples to contest against the null hypothesis. Therefore, we cannot come to a definitive conclusion. At part 6, the 95% confidence interval is between 39.4451 and 43.8931. To get 95% confidence interval, we take the sample mean minus the margin of error and sample mean and add the margin of error. The value in between this range could contain the true population parameter.